So once again, welcome to our class. The topic we have this quarter is all about triangle inequalities. So let us proceed. So there are three theorems in triangle inequalities. The first is the triangle inequality theorem, exterior angle inequality theorem, and the hinge theorem. So the triangle inequality theorem, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So the length of two sides of triangle is greater than the length of the third side. So A plus B is greater than C. Yes. And if A plus C is greater than B, and the sum of B and C is greater than A. So that's the triangle inequality theorem. The sum of the lengths of two sides of a triangle is greater than the length of the third side. So next, the exterior angle inequality theorem. So the exterior angle of a triangle, this one, is equal to the sum of the two opposite interior angles. So the sum of these two angles or interior angles is equal to the exterior angle here. So that's it. That's exterior angle theorem. The next is the hinge theorem. So if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So larger and longer. So that's hinge theorem. So if the two sides of the angle, yes, the two sides of the angle are congruent with another triangle, then the included angle of the second included angle of the second is the first is larger than the included angle of the second here. Then the third side is longer than the third side of the second. So that's it. Okay, axioms of equality. So number one is reflexive property of equality. So before we can prove theorems, let us go back to the axioms of equalities. So reflexive property of inequality: for all real numbers of P is equal to P. So that's the reflexive property of equality, same as the identity reflexive property of equality is for example, this is a triangle and you cut it in half. So here angle A this is angle A, B, C, D. So the segment AD is reflexive, is congruent to the AD. same. It's the same. It's reflexive property of equality. So the symmetric property of equality for all real numbers p and q. If p is equal to q, then q is equal to p. So uh, it is symmetric. If p is equal to q, then q is equal to p. And transitive property of equality for all real numbers p, q, and r. If p is equal to q, then q is equal to r, then p is equal to r. Yes, that's transitive property of equality. And substitution property of equality for all real numbers p and q. If p is equal to q, then q can be substituted for p in any expression since they are equal. Properties of equality. Addition property of equality. So for all real numbers p, q, and r, if p is equal to q, then p plus r is equal to r. Yes. Next, multiplication property of equality for all real numbers p, q, and r. If p is equal to q, then pr is equal to qr. So they almost the same, but it's addition and multiplication. So definition, postulates, and theorems on points, lines, angles, and angle pairs. So the definition of a midpoint. So the definition of a midpoint: if P, Q, and R are collinear or in the same line, and Q is the midpoint of PR, then PQ is congruent to QR, like this. Okay, this is P, P, this is P, and then here that's point. I can make a point. This is R. So here let's say this is the midpoint Q. So if the midpoint of P and R is Q, then PQ is PQ ang segment PQ is congruent. So PQ is congruent to QR. So since the midpoint is Q. Okay. Next, definition of an angle bisector. If QS bisects angle PQR, then PQS is congruent to SQR. For example, this is an angle. This is Q. This is R. Sorry, and this is P. This is P. This is R. So the angle bisector, which is S. So if QS bisects PQR, it means that angle PQS is congruent to SQR. So I'm sorry if I cannot make a straight line. Okay, next, segment addition postulate. If PQ and R are collinear or in the same line, and Q is between points P and R, then PQ plus QR is equal to PR. So that's it. If PQR are collinear, then Q is between points of P and R, so the sum of PQ and QR is equal to the PR. angle addition postulate. If point S lies in the interior of M, the measure of angle PQS plus the measure of angle SQR is equal to PQR. So the definition of supplementary angles: two angles are supplementary if the sum of their measure is 180 degrees. Yes, the sum of two of the two angles are measured at 180 degrees, and for the complementary angles, two angles are complementary if the sum of their measures is 90 degrees. Definition of linear pair: linear pair is a pair of adjacent angles formed by two intersecting lines. Yes, adjacent angles formed by two intersecting lines. And the linear pair theorem: if two angles form a linear pair, then they are supplementary. Yes, like this. If this is the sum of this here, this is 180 degrees. That's supplementary. So if they form a linear pair. Definition of vertical angles: vertical angles refer to non-adjacent angles formed by two intersecting lines. So vertical angles is like this. Yes, so vertical angles theorem: vertical angles are congruent. So um, it is not a straight line, but it is the example of vertical angles. Definition of theorems on angles: the sum of the measures of the interior angles of a triangle is 180 degrees. Definition of equilateral triangle: an equilateral triangle has three congruent sides. So it is from the word equal, the equilateral, equal sides and congruent sides. Definition of isosceles triangle: a triangle with two congruent sides is called isosceles. So there's two congruent sides only. So just like this, the two are congruent. Isosceles triangle theorem: base angles of isosceles triangle are congruent. Yes, and the exterior angle of a triangle. An exterior angle of a triangle is an angle that forms a linear pair with an interior angle of a triangle when a side of the triangle is extended. Yes, just like this. If it is extended. No. So this is an angle, and no. So this is the exterior angle. Yes, exterior angle of the triangle. So exterior angle theorem: the measure of an exterior angle of a triangle is equal to the sum of the measure of two remote interior angles of the triangle. So we have discussed it a while ago that the sum of two interior angles is equal to the exterior angle. Sides and angles of the triangle. So here angle S, and angle E, angle C. So angle S is the opposite of EC. EC and EC is the opposite of angle S. So same as the angle E is the opposite of EC, and EC is the opposite of angle E. So that's it. Definition and postulates in triangle congruence. Definition of congruent triangles. Two triangles are congruent if and only if their vertices can be paired so that the corresponding sides are congruent and corresponding angles are congruent. So, congruent triangles if two corresponding sides and angles are congruent. Included angle. Included angle is the angle formed by two distinct sides of a triangle. Yes, included angle is the angle formed by two distinct sides of a triangle. Okay, this is the included angle, two distinct sides of a triangle. So, angle YES is the included angle of segment EY and ES. So, angle EYS is the included angle of YE and YS. So, the angle YSE is the included angle of SE, segment SE and SY. So, that's it. Included side is the common of two angles of a triangle. The segment AW is the included side of angle YAE and EWA. So, angle at the segment AW, yes. And the segment EW is the included side of AEW and AWE. Angle side of the segment AE is the included side of WAE and AEW. So, and also the SSS or the side triangle congruence postulate, the side angle side triangle congruence postulate, and the ASA angle side angle triangle congruence postulate. So, properties of inequalities. For all real numbers P and Q, where P is greater than 0 and Q is greater than 0. So, this is the property of inequality. If P is greater than Q, then Q is less than P. If P is less than Q, then Q is greater than P. So, for all real numbers P, Q, R, and S, if P is greater than Q and R is greater than equal to S, then P plus R is greater than Q plus S. So, that's it. For all real numbers P, Q, and R, if P is greater than Q and R is greater than 0, then PR is greater than QR. So, if P is greater than Q and R is greater than 0, then PR is greater than QR. Number 4. For all real numbers P, Q, and R, if P is greater than Q and Q is greater than R, then P is greater than R. Really. Then for all real numbers P, Q, and R, if P is equal to Q plus R and R is greater than 0, then P is greater than Q. Yes. Okay. Here, Q is the midpoint of P and R. So PR is equal to PQ plus QR, or the sum of PQ and R. Then PR is greater than PQ, and PR is greater than QR. Okay, next, the angle 1 here, the angle 1 and angle 2, angle 1 and angle 2 are adjacent angles. Okay, they are adjacent angles. The measure of PQR is equal to the measure of angle 1 and measure of angle 2. Then the measure of angle PQR is greater than the measure of angle 1, and measure of angle PQR is greater than the measure of angle 2. So this is the theorems, the postulates, and the properties that we're going to use in our proving. So that's all. Thank you.